Well, hello my dear students, how are you all? Welcome to Deeksha Karnataka YouTube channel. I hope all of you are doing really good. Okay bacha, so today I'm back here with another session in a Masterstroke on the chapter Application of Derivative. So what I felt bacha in your sessions for check review on this particular chapter, that you were not able to answer all the questions, okay, comfortably. The goal is to solve any questions comfortably, okay. If you are able to do that, means you are prepared for examination. So but I felt there was some difficulty that you were facing or something else, okay, in your chapter when solving the questions in MCQ series, okay. So that's why this session becomes very important. If all of you are here watching this particular video, you have to clear all of your doubts in this particular video itself. We don't have much time to put a lot of your energy, lot of time on one chapter. We have to do quickly learn it, completely learn it and move on to the next chapter, right? So for that, please pay your complete attention and solve the questions that I've taken in this chapter. So yes, I've taken a total of 5-6 questions today. Apart from, I will explain you the different types which is there, type of problem which is there in this particular chapter. For example, on the increasing decreasing function, on the maxima minima, okay, first derivative test, second derivative test, all of that will be discussed in detail, of course. And I'll as I said, I will also solve bacha 5 to 6 questions. So I hope you're ready for that. Please maintain bacha the energy. I don't want you to miss out on some marks. This is again a very high weighted chapter, it's not a low weighted chapter, and you have learned differentiation, right? This is very simple. After that, just some concepts, if you know, you can solve any questions from AOD, right? So I hope you are ready for that. Let's start with the question. So before I move on to the question, sir, we have some things to learn. Yes, bacha, this is one shot, right? So we'll complete entire chapter. Okay, we'll go to the question, but we'll complete entire chapter first. Rate of change of quantities. So what we learned over here, bacha, means how can one variable, what is a variable, sir? It can be assigned to any quantity. For example, I can assign a variable v to the quantity, velocity or volume, right? I can assign a variable a to the area. Okay, so rate of change of any variable, okay, with respect to another variable. For example, how fastly or how slowly the area is increasing when the time is increasing. For example, you throw a stone in a lake, okay, the ripples keep moving forward, right? So radius keeps increasing. So how fast is the radius increasing there? Okay, some cases what happens, the radius is decreasing. Okay, there can be a question given, right? So for example, a balloon is already inflated. What you do is you keep a puncture in that. What happens, bacha? It keeps shrinking now. So what is happening over there? Radius is decreasing, sir. Okay, so what I'm trying to say is, for different cases, we can learn to understand the rate of change of a particular quantity with respect to another. Okay, so that's what is written over here. Please check in the geometric interpretation of the derivative. If y is a function of x, y is a function of x, is a single valued function of x, x changes to x plus delta x, means when the x is bacha changing from x plus delta x, okay, the corresponding value of y will also change from y to delta y, means some change in x will make a change in y, and this bacha, this is called as the rate of change. This is called as the rate of change, delta y upon delta x. When this x value becomes, when this change value bacha becomes very simple, smaller, this is called as what, sir? Change. Okay, the change. All right, when this bacha, this particular value, if I write over here, when this value delta x becomes very small, very small, okay, when the change is very small, bacha, what will happen? This value will become dy by dx. It will become dy by dx, right? That's what it was. Remember, for example, I can explain you with this concept. Remember this, I can draw a curve like that. Okay, take your chord like this. I can draw better, just give me 1 second. Okay, yes, chali. So if you have a look at this, I have a curve like this. I can draw a line like this, bacha. I can mention these points over here as x1 and x2. Over here, bacha, I have y1 and y2, right? Okay, so what we do over here, y2 minus y1 is what, sir? Is basically my change in y. And when this happened, whenever you had this bacha x2 minus x1, which is what, sir? Delta x. Which is what, sir? Delta x. Whenever I make this delta x 0, what it means, sir? It means whenever I make this point come together, whenever I make this point come together, for example, I take a tangent, sir. I take a tangent like this. At the point x1, I take tangent, bacha, means what happens is my point x2 is moving towards the point x1, sir. The point x2 actually is moving towards the x1, so what will happen, bacha? This will become one single point, and the chord of this curve will be what, bacha? Will be nothing but a tangent. Will be nothing but a tangent. Then what happens is, simply we can call, sir, simply we can call this change delta y by delta x to be dy by dx, no? Right? That's the slope of a tangent, right? This is called as dy by dx, no? When you, what is this called right now? It's slope only, right? This is slope only, right? I know it's messy, but please, very important to understand this. This is the formula of slope, delta y upon delta x, right? So whenever this x2 moves towards x1, but what is going to happen? Your delta x will become almost equal to 0. Okay, so this will turn out to be dy by dx, and what is that called as? Derivative of a function y at x, okay, and that's nothing but the slope, of that curve at the given point, slope of the curve at the given point. What point, sir? At the point x1. Please let me know if you understood this point. Very simple thing, just wanted to mention it over here, okay? If not, again I will come up with a session and explain this part again. Okay, simple thing, you don't have to worry about too many things over here. Just understand this rate of change, delta y by delta x, when this delta x value becomes equal to 0, not exactly 0, tends to 0, what happens is this conversion to dy by dx. How come, sir? Because this chord becomes the tangent. It will have a 1 point contact, right? It will have a 1 point contact. Okay, this is called as rate of change. Chaliye. So now I have a very important announcement to make for all of you. What is that? Regarding bacha your Abhyas KCET test series. A lot of you were asking in the live sessions and other videos as well, comment section. So when are you launching the test series? Bacha is already launched. Okay, launched on 7th of February. Go ahead, you can access the free part right now. So what we have done is, we don't want you to invest a lot of money right away. So what we have done is, we have given you 4-part test free. What I mean by that is, like, you'll have a 60 question per paper for physics, chemistry, biology and maths. Of course, you'll have 4 subjects. Each paper will be given to you. Each will have 60 questions. Okay, you can access that right away for free. Try it out. If you feel it is very good, then only you can decide to invest your money in the test series. But I will certainly request you to do that. It's not a big amount. It's a very important thing to get ahead, to be prepared in your examination for KCET 2025, right? So it's the right time to invest, bacha, because the price right now is going for $14.99. Okay, after some time what will happen, this might increase. So please avail this offer right now. This is launch offer, so please avail this offer right now. Okay, also if you are a PU2 student, you can get the PU2 success blueprint test series for 1 rupee. Of course, you have to purchase this first, then you can add 1 rupee and get this total value for $14.99. Got it? Okay, so please make sure that you are somebody who has taken this test series right away. All right, what are you gonna get in that? You're gonna get a total of 35 full syllabus tests, okay, and chapter wise tests as well. So what else is there, bacha, over here in 35 free test paper? So you have 4 free test paper and 31 full length papers. Okay, means paid papers. Okay, that will start from 17th of March. So free papers are available right now on our platform. Once you purchase it, once you access it, purchase means bacha at 0 cost. Okay, once you purchase at 0 cost, actually it's 0 cost. Once you purchase, you can access the 4 tests. If you are going further, and you should go for the full test, bacha, then what will happen, you can get this test 31 test paid tests from 17th March. Again, you'll get from 17th March, but you can buy right now, because what will happen now, might be closing to the KCET examination, the prices might increase, bacha, because of the high demand, right? We'll have a difficulty maintaining everything. For that reason, the team will be bigger to work around. That's why it might increase. So please purchase it right away. Okay, you'll have a detailed video solutions for this and analysis of that. You have chapter wise one-shot revision videos, okay, and you'll have chapter wise insights for last 5 years for KCET papers. Okay, these are very, very important features of the test series. Please go ahead, check it out. The link for this web page, link for the test series will be given in the description of this video. You can go ahead, click that and check it out. Okay, so let's get back to our one shot, velocity and acceleration. So if the function is what, sir? If the function is given as bacha displacement function, if it is a displacement function, bacha, okay, it's a displacement function, then if you differentiate it once, you get a velocity function. Differentiate once, you get a velocity function. Check this out. First derivative, what is that, bacha? First derivative. If you differentiate this function 2 times, you get acceleration. What is the second derivative? Achha, one more thing, to download these notes, bacha, you can go to the WhatsApp channel. The notes PDF for the sessions will be provided there. If you have not joined, join it right now. If you have joined, then good, you'll get it delivered in your WhatsApp channel only. Okay, so acceleration is what, bacha? It's going to be second derivative of your displacement function, and your velocity will be first derivative of your displacement function. Is that clear? Okay, so what do you do? Check this out. ds by dt will become f dash of t. on if you differentiate either velocity or the second derivative of the displacement function, you'll get this as acceleration. Again, this is something called as jerk. Okay, what is that going to be? It actually looks like a jerk. Okay, and it will be third derivative, or basically derivative of the acceleration with respect to time. Okay, so a third derivative of the displacement function is gives the jerk. Okay, it is aptly named because a jerk means a sudden change in acceleration which causes an abrupt movement in the vehicle. Sudden change in the acceleration causes a, you might have felt it, right? Jerk you don't feel while driving in a car or in a bike. If you drop the velocity right away, or if you increase the velocity right away, you feel the jerk, right? That's what is called sudden change in the acceleration. Means sudden change in the acceleration drops quickly with respect to time. Okay, chaliye. So this is very simple things. Now question number 1 is based upon that. Let's quickly solve it. The displacement s on a moving particle at a time t is given by this. What is this called, sir? This is given here as, one second, displacement function. So you have here given as displacement function is given like s in the variable t is given as 5 plus 20t minus 2t square. Now what are they asking? Find the acceleration when velocity is 0. When the velocity is 0. Okay, chaliye. So how to find what's the acceleration? You have to take this a equals to either dv by dt or simply d square s by dt square. We have learned second order derivative as well, so why not finding this directly? Yes, we can do that, sir. Let's do it first. So we get here ds by dt will be bacha 5 will become 0, this will become sir 20, okay, and this will be sir minus 4t. Alright, minus 4t. Okay, now what is next going to be? D square s by dt square. This will become, so 0 is already gone, this will become 0, so it will be minus 4. Will give me this as minus 4 meter per second square. Meter per second square, or simply units. Option number B is correct. Please check. This doesn't play any role over here because there is no velocity involved in this. It's a constant value, right? That's why simply minus 4 meter per second square is your acceleration. Clear, right? Not a problem. This is going to be bacha your acceleration only, no? Okay, let's move on to second question. If the radius of the spherical balloon increases by 0.1%, then its volume increases approximately by how much? Think. What is they have given, sir? They have given here delta r, right? Change in the radius, no? Change in the radius, sir. They have given delta r is equals to, have a look, 0.1% of r, right? Increases by 0.1%. What increases? 0.1% of the radius, no? Okay, so I can write this as delta r equals to 0.1 by 100 into r. How much is that? 1 by 1000 times r, right? This is your delta r. Okay, now how about this bacha? dv by dr. So dv by dr will become, have a look, derivative of volume, sir, of a spherical balloon, 4 by 3 pi r cube. Agreed. Let's differentiate it. You're gonna get this as 4 by 3 times 3 pi r square. 3 and 3 is cancelled. What I'm getting here is 4 pi r square. This is the value of dv by dr. Chaliye. Now what are you looking for? Change in volume, right? Volume increases. So delta v bacha will be nothing but equals to dv by dr times of delta x, sorry, not delta x, delta r, excuse me, radius over here. Can we have the values now? What is this going to be? d by dr is, sir, 4 pi r square, 4 pi r square, okay, and delta r is over here 1 upon 1000 times of r. Agreed? Correct, right? Check this out. We can write this over here also, no? That's how we'll take in here. This is like this. Delta r is over here. I've taken this on this side. That's how it has come over here. So I hope that part is clear. I'm going to erase this from here now. Okay. All right. Let's have a look now. So from here, what we are getting, delta v, changing the volume equals to, multiply this r with here, bacha, will become 4 pi r cube 1 by 1000 multiply here, sir, by 3 into 3. How, sir? This will become volume formula, no? That's why I multiplied with 3 and divide by 3. So check this out. It will become, sir, V. It will become, sir, 3 by 1000. How much is that? 3V by 1000. This is the value. What is they looking for? Percentage, no? To divide, multiply by 100, no? 3 by 1000 into 100, right? What we get, sir? This is cancelled. I'm having here 0.3% of V. So change in the volume is nothing but 0.3% of the original volume V. Okay, how much is that? Over here, option B is correct. I hope this is clear. Please check. Right, this is clear, no? Have a look. So first what you did, you got the value of delta r, changing the radius, okay, in terms of the original radius r, and dv by dr you found as 4 pi r square. Later you use this formula delta v, and that came as 0.3% of v, the original volume v. Okay, let's move on to picture question number 3. Actually, before that we have one more concept. So first part, the rate of change is covered. Let's move on to increasing and decreasing function. Okay, so far let me know how you felt about the first unit in the AOD. Excuse me. So when can we call a given function increasing or decreasing? Okay, so again we have two types of increasing functions, so increasing and strictly increasing, increasing and strictly increasing. So what is happening over here? If x2 is more than x1, what happens, sir? If x2 is also greater than or equal to x1, f of x1. So what I'm meaning by this is, increasing function will be like this, bacha. So I can have a function like this. This is an increasing function, sir. This is a increasing function. But this over here, okay, like simply like this, okay, or simply like this. These are all strictly increasing function. Whenever there is no, this part here, you can see there's a constant part over here. Whenever you have that involved, you can call the function to be increasing, whereas there's no part like that. Function, when the value of x increases, what is happening to the y value? Is increasing all the time. When the x increases from left to right, what happens to y, sir? Always keeps going up, up, up. Okay, that's why what is happening, this is called as strictly increasing function. Wherever in the case of increasing function, what happens here is there will be some part where it might have a constant part. It will never be decreasing in nature, but it might be constant at some point of time. For example, when you look at the graph, when you're melting the ice or when you're heating the water, so that's at the latent heat part, what happens is you'll have a line parallel to the temperature curve, right? So this is clear, no? So this is going to be an increasing function. This is going to be a strictly increasing function. Same way, if we look for decreasing function, we'll have this. So this will be, this will be your decreasing function. This will be your decreasing function. Have a look. Okay, and this will be your strictly decreasing function. Strictly decreasing function, bacha. This is strictly decreasing function, where this is simply decreasing function. Clarity is there? At this part from here to here, what is happening, sir? The graph is constant for some time. That's why only decreasing, whereas in this particular case you can see strictly decreasing means as x increases, y value is simply decreasing all the time. That's why strictly decreasing. Have a look. So whenever you see strictly decreasing case, you don't have equality over here. Strictly increasing case, no equality over here. Okay, so yes, this is also greater than, this is also greater than, this is also less than, this is also less than, not a problem, but equality is a difference. Over here there's the equality, means just in decreasing function. Over here no equality, this is not less than equal to, simply less than. Less than equal to means decreasing function, simply less than means strictly decreasing function. Strictly decreasing function, there's a difference. Okay, so I hope this is clear. I have explained you with this graph to you. Okay, simple graphs, nothing much is there. Okay, now first derivative test for decreasing and increasing function. What do you do over here, bacha? Very simple. If you have, so what first thing is, for a function given to you, what you do first thing, find bacha derivative. Find the derivative. Okay, once you get derivative, so in the interval put any value to it. Any value do you put? If you get this as greater than 0, you call the function to be increasing. What I mean by that, sir, if derivative of the function at that point is coming as greater than 0, bacha. Okay, check this out. X belongs to the interval a comma b. interval a comma b. When you get that, what do you say? You say that function is increasing in that interval. Same way, if you get derivative, this is bacha will give me increasing function. When you set sir derivative is less than 0, you'll get the bacha the function to be decreasing in nature. Derivative is less than 0, you get bacha function is decreasing in nature. Constant bacha, it means you'll have simply derivative equal to 0. You have to find the critical point from there. You have to find what? The critical point from there to check out the values. Okay, don't worry, we'll show you sir over here. How do you do that? How do you find critical points? Have a look. Find working rule to find the intervals in which function is increasing or decreasing. So over here I'll tell you this part. A constant is given. How do you find that? Simply you do that to get what value of, you put it equal to 0 to find the value of constants or find the value of critical point. Okay, usually you don't get the case of third. First and second is more than enough. Have a look. Okay, chali. So what we have over here is find the interval which the given function is decreasing, in which the given function is decreasing. Function is given like this. Have a look. Fx equals to 10 minus 6x minus 2x square. How do you do that? Find the derivative. First step is to find the derivative. Step 1 is bacha, this is your step 1. Find the derivative. Okay, so it becomes 0 minus 6 minus 4x minus 4x. Second step bacha, finding critical point. So put derivative of the x equals to 0. From here what are you going to get? Minus 6 minus 4x equals to 0. From here you get 4x equals to minus 6. Here you get x equals to minus 3 by 2. X equals to minus 3 by 2. Is this clear? Please check. Is this part clear, sir? So far you have got the critical point. This is called as critical point. This is called as critical point. Now in a question there can be bacha more than one critical point also. In a question there can be more than one critical point also. Over here we have only one. Okay. Step 3, sir. Step 3 will be bacha doing what? Plotting on the number line. So draw a number line like this. Okay. Put the value x minus 3 by 2. Okay. Now what you do after this is take a value right after and before. So let's say after this 3 minus 3 by 2, what we can get? This is negative 1.5. No, I can take bacha 0. 0 will be here. So put x equal to 0 in the derivative. Okay. So step 4 will be, step 4 is actually part of step 3 only. Put x equals to 4. X equals to 0 in the derivative. What are you going to get? Check this out. If I put sir f dash of 0, what is that going to be? Check this out. It will become minus 6 minus 0. No, what is that? Minus 6. So what we are getting, sir? F dash or 0 bacha is less than negative. No, it's going to be negative, right? Check this out. On the right side value 0 is somewhere over here, right? So at 0 what we are getting, sir? Derivative is coming as minus 6 means negative, sir. It means negative, sir, hence decreasing. Okay, and if you put a value over here, no, what will happen? Check this out. You can put here minus 2. Let's put this value over here as minus 2. What are you going to get? So if you check this out, f dash at minus 2 will become, sir, minus 6 minus 4 times of minus 2. How much is that? Minus 6 plus 8. How much is that? 2. So we are getting f dash of minus 2 as greater than 0. Greater than 0. What is going to happen? It will be positive, sir, on this side. Okay, hence increasing in nature. What we are looking for? Only decreasing. So we'll look for that interval. Where our answer will be this interval. Step 5, write your interval. So decreasing in where bacha? From minus 3 by 2 to infinity. On this side, right? If you go on this side, it's negative, no? This side is negative, sir. Please check. Please have a look. This side is negative, sir, whereas this side is positive. Okay, so what is your answer? Decreasing in the interval minus 3 by 2 to infinity. That's your answer. Please check. From minus 3 by 2 to infinity on this side. This is clear. Have a look. Now, so this is very, very important actually, because this kind of question comes in your boards as well. In your similar concept based question comes in KCET as well. So that's why very, very relevant to you to understand any questions coming on this particular topic. So please, I hope I was able to complete your this particular topic and clear the doubts from there as well. If you have any, let me know in the comment section that sir still want to have some more clarity on this. Okay, please check. This is done. Working rule to find the interval in which function is increasing or decreasing. Next question number 3. What we have here is the function is given like this: fx equals to x cube minus 3x square plus 3x minus 100. Look for bacha this function's nature, increasing, decreasing, not increasing, like that. Chaliye, let's solve this. So what is the first step? If you remember, derivative we have to find out. It will come as 3x square minus 6x plus 3, and that will be bacha 0, no? So what I get over here is, take 3 common, I get x square minus 2x plus 1. This is nothing but x minus 1 the whole square, no? X minus 1 the whole square, right? Please check. X minus 1 the whole square. X square plus 1 minus 2x. Now you only tell me, from here bacha what we get? F dash of x will be always greater than 0. Can it be 0, sir? When x equals to 1, it will be 0. Apart from that, it will be always greater than or equal to 0. Okay? Hence, what, sir? What will happen, bacha? Increasing in nature, no? It will have no constraint. Means for all x real values, for all real numbers, what will happen? For all real numbers, this function fx is increasing in nature. Fx is increasing. My answer will be option number A. Please check. I hope this makes sense to you. Derivative is, sir, positive, no? Or it can be 0 as well. So both conditions will satisfy for the condition of increasing function. Hence, x for all real, the function fx is increasing in nature. Answer is A. No interval as such. All interval. What is the interval, bacha? All real. Okay. So they can ask you the function is increasing in which interval? They'll be given options like that. You have to choose all real. What is the answer? All real. Okay. Now the last part of this particular chapter, what is that going to be? Maxima and minima. Okay. This is the most important part again. Not difficult at all, but as I said, this chapter has 3 parts in it. First part was rate of change of quantity. Second part was your increasing decreasing function. I have given the steps to solve in the interval as well. And the third part, which is going to be maxima and minima. Okay, please have a look. Let fx be a real valued function. Define an interval I. Then fx is said to be having maximum value in interval I if there exists a point A in the interval I such that f of A is greater than f of x for all x belonging to the interval I. Sir, doesn't make sense to me. If somebody is able to understand this, then very good. But if somebody is not, don't worry. I am here for all of you. If bacha, if I show you the graph over here, let's say this is the function, okay? Then let's say I'm defining the function from here to here only. I will define the function from here to here only. This is my interval, A to B only. Will not consider this part, okay? Will not consider this part. All right. So, or what is the point I've taken? F of A, right? So I'll make this to B to C actually. I make it to B to C. I can do that. Let's call this function bacha defined interval as I equals to B to C. B to C. That is acceptable, right? I'm defining the interval I. I've already mentioned here the interval I, okay? So I'm defining the interval I in this particular case as B to C. Then bacha what will happen? There will exist this point x equals to A, okay? When you check f of x, okay? When x equals to A is called as what bacha? It's called as f of A will be highest. Can you see this over here? Will be more than any point. If you take this point over here, no? Basically, if you go either side, let's say delta value, you go this side, delta value, you go this side as well. Okay? What will happen, bacha? What will happen, sir? So f of A will be more than, okay, not equal to in this case, more than actually f of A plus delta. Also, f of A will be more than f of A minus delta. Means in the neighborhood of this point A, this value A will be highest. Will be highest, okay? But delta is a very small value. Delta is a very small value. This is called as the functions fa. This will be bacha point of maxima. Maxima. And f of A will be called as maximum value. Okay? F of A will be called as maximum value. Again, this A has to be where, bacha? This A has to belong from the interval I only. Correct, na? This A belongs from the interval I only, B to C. Doesn't A lie in the interval B to C? Yes, sir. From B to C means A will be part of that, no? Yes. This is the point of maxima. What will happen, bacha, for point of minima? Think about it. Same graph, just reversed. Okay? So if this is, let's say, point B over here, point C over there. I take a point A where A belongs to the interval I. And what is interval I, sir? Interval I is bacha B to C again. What will happen, sir? F of A would be less than any point. So f of A plus delta and f of A will be less than f of A minus delta as well. Means whether you go this side or this side, if this is let's say delta and delta minus and plus, what will happen, bacha? Whether you go this point or this point, what will happen? This f of A will be the minimum value across the function in that given domain or given interval. Then we call the function to be minima. This is called as point of minima. This is called as point of minima. I hope this is clear. Please check. So fx be a real valued function and interval. Okay, in an interval I, fx is said to have a minimum value if, what is there? F of A is less than fx. Where what is x, bacha? From any interval, from the interval I. What I've taken interval here as B to C. Please check. I hope this makes sense to you. If you have a doubt in this part as well, let me know in the comment section. Okay, let's move on now. First derivative test. So how do you find, bacha, the maximum and minimum point? So one way to do it is, I'll show you. Let's say I have, this is the function. This is my function, okay? This is my function. Now if I'm asking you to find at this particular point, whether check this point is a point of maximum minimum. We can see from the graph it's a point of maxima. How can we justify that? Do one thing, find the derivative of the point before and after. So if you find, bacha, over here, derivative of this point over here, it'll come as like this, it'll be tangent to this curve at this point, and if you find it like this, it'll come it like this. So we have two different slopes, sir. One of this slope is like this, okay, other slope is, bacha, like this. Theta 1 and theta 2 we can call. Think about it. Here the slope is, sir, positive, acute angle, no? So tan theta 1, bacha, is positive, whereas tan theta 2 is negative. You know, right? Tan theta 2 will be, sir, angle will be obtuse over here, right? This angle is obtuse over here. Okay, not clear? I can draw this graph over here as well if you want me to. Chaliye. So let's say this is the graph, okay? I'll take the little sharp. If I draw the tangents, okay, at the point before and after of this point, let's say x equals to A, I take this point to B and draw a tangent over here. It'll come like this. And for this point, bacha, tangent will go like this, okay? So this is, sir, obtuse angle theta 2, and this, bacha, is going to be obtuse angle. What I have? Tan theta 1 will be, what's, sir? Positive, and tan theta 2 will be negative. So you can see here, slope is negative over here, is positive over here. What is this called as? Simply, slope is a derivative only, no? This is called as slope only, right? Okay, so whenever you have basically f dash of x positive, okay, and f dash of x negative, so change, bacha, across this point A is going from positive to negative. So derivative f dash of x is moving from plus towards minus. The sign of the derivative is changing from where, bacha? The sign of derivative is changing from plus to minus. You call that point to be point of maxima. I'll repeat myself. Whenever you have sign change for the derivative from plus to minus, sign change of derivative from plus to minus, what is that called as? Point of maxima. Please check. Whenever you have point of maxima is where? When the derivative changes sign from positive to negative. F dash of A has to be 0, of course, okay? Why, bacha? To get the critical points, no? To be able to find. If this is not there, we can't find, bacha, maxima or minima. Derivative has to be equal to 0 at that particular point, and fx should change the sign from positive to negative, plus to minus. When it does that, the function is what, bacha? Giving me a local maxima point at this particular A value. Local maxima point. Again, opposite is there in case of minima. I can show you that over here only. Can I erase this? Okay. Local minima I show you. If you check the local minima case now, what will happen, sir? In local minima case, the graph will be like this, bacha. Okay, draw the tangents. For this point, let's say I'm pointing out, this is my tangent on this side, and this is a tangent on this side, right? The two tangents, okay? I'll again take the values. Check this out. This, bacha, is going to be obtuse, right? Theta 1. And this is going to be, sir, acute, no? This angle over here for this part. Okay, acute, right? So what is happening, bacha? For this part, if I call the slope, if you check it out from left to right, what is happening? The derivative was negative here and changed to derivative as positive here. Where sir positive, where negative, sir? I'll show you. This part where angle is obtuse, this particular line. Okay, what is happening here? Derivative is negative, sir. On this line, positive, sir. Whenever the derivative changes from minus to plus, sign of derivative, the sign of the derivative changes from minus to plus, what will happen, sir? The function will be minima. Please check. Sign changes of the derivative from negative to positive. Okay, what will happen, sir? Point of local minima. Local minima. Get it? Of course, this has to be there. First thing is, derivative at that point has to be equal to 0, sir. Means this point has to be, this point A has to be one of the critical points. Is that clear? This point A has to be one of the critical points. Then only it will be 0, right? Yes. How do you find what's a critical point? By putting the derivative equal to 0, right? That's what it's saying, no? Put the value A over here, it'll come as 0. Okay? Don't worry. Check it out. So this is the understanding of your minima and maxima. Okay? If derivative of x is negative at every point sufficiently close to and on to the left of A, and f of x is greater than 0 at every point or sufficiently or close to and the right of A. Same thing, no? This is sir right of A is positive, bacha, and left of A is negative, sir. This is what, bacha? Left of A. All right, and this is sir right of A. Right of A. Right of A is positive, left of A is negative. It's called as local minima. Alright, last is point of inflection. What happens over here? No sign change, sir. For example, check this out. Over here, this point is point of inflection. I can show you. If you take a tangent on this side, it will come like this. On this side also, positive only, no? Positive and positive. Both is positive, bacha. So no sign change. Or also whenever you see the concavity is changing, concave up to concave down, concave up to concave down. That's called as point of inflection, bacha, right? We have learned that, no? Remember this? Whenever the concavity or convexity is changing, please check. So f dash of A has to be of course 0, and f dash of x does not change its sign. Okay, as increases through A means whether you go from left to right, any point you go, the sign does not change. F dash of x sign remains unchanged, remains same or unchanged. When that is there, it means it's called as point of inflection. Okay, that is f dash of x has the same sign in the complete neighborhood of A, then A is neither a point of local maxima or local minima. In fact, such a point is called as point of inflection. Simple way to get this is simply whenever the concavity is changing, bacha. Concave up, concave down. Please check. Got it? If you have a doubt, let me know in the comment section. But I've tried to clear it. Chaliye, so let's move on to bacha questions now. Acha, this was the before I move on to question, we have learned right now was first derivative test. This was bacha first derivative test. Actually, sometimes very confusing to this part, right? But there's a simpler approach to that. What is that? Second derivative test, sir. Isn't this difficult? Does the name go second derivative is difficult, right? No. Actually, first derivative test might be complicated at times, but second derivative test is always simple. Second derivative test is very, very simple. Agreed? I'll show you how. Do one thing. Function fx is given to you, no? Fx is given to you. Find derivative from here. Find derivative from here. Okay? After finding it, put it equal to 0. Get the critical points. Get the critical points. So this part is common. This you do even in the case of first derivative test. After getting bacha critical point, what do you do? Find the second derivative, bacha. Find the second derivative. And for all the critical point, you put the values. Okay, let's say critical point is coming as A and B. Now if you are getting second derivative at A as let's say positive, you call A to be point of minima. Point of minima. No need to check here the graph trend. No need to know the graphs. Okay, only thing is find the first derivative to get the critical points. Okay, and find the second derivative, put the value of this first the critical points in the derivative. If it is positive, bacha, then point of minima. If the derivative is, let's say for point B is coming as negative, bacha, will be, so B will be a point of maxima. Point of maxima. Is that clear? So B, f double dash of B is coming as negative means B will be a point of maxima, and again the maximum value and minimum value will be coming like this. F of b will be your maximum value, this is your max value, okay, and same way f of a bacha will be your minimum value, please check. If f dash of a is 0 and f double dash of a is less than 0 means negative, point of local maxima. F of a is 0 and f dash of a is negative means less than 0, point of maxima. First point is clear. Check here, f dash of a is 0 and f double dash of a is greater than 0 means it will be a point of minima. Check here, positive, right? Positive, right? Okay. Chali. If you are getting bacha this case, no, when both are coming 0, use the first derivative test bacha to get the change in trend. Okay. Check the trend from using first derivative test. Okay. Same thing is given over here. And the last one that we got, point of inflection, please check. Okay. Now we can solve the question. Question number 4. Maximum value of the function given like this on the interval 1 to 6. 1 to 6. Have a look. This is very, very important, bacha. I'll show you how. F of x is given here as x by 8 plus 2 by x. First step, very simple, find the derivative. It'll be 1 by 8. How come? For x it will be 1, right? Yeah. So this part you'll have, bacha, 2 is a constant. Minus 1 times of x power minus 1 minus 1. So 1 by 8 minus 2 upon x square. This is your derivative. What I asked you to do, after finding derivative, put it equal to 0 to find the critical point. So put it equal to 0. What I get? 2 by x square equals to 1 by 8. What I get? X square equals to 16. What I get? X equals to plus minus 4. Now will you take plus minus 4 both? No, sir. Check this out. You have only 1 to 6 interval given here. It means only value which is going to be taken here is x equals to 4. X equals to 4. We can't take minus 4. How come? Because bacha, what will happen here is the interval is defined, no, 1 to 6. Negative 4 is not part of the interval. That's why you neglect the minus 4 value. Now once you get this, if you want, you can check this out as well. Second derivative test. Check it out. What is that going to be? Please check. What we have here is, if differentiate, it will become 0. And this will become, sir, minus 2 into minus 2 x power minus 3. So plus 4 by x cube. Okay, plus 4 by x cube. 1 second. So this will turn out to be positive. Put x equal to 4 over here. It will become positive only, no? It will be positive value, right? So it is what is going to be. But we can't take bacha 4. But we can't take bacha negative of 4. Okay? Because the interval is defined 1 to 6. So x value will be turning out to be plus 4. So find the value of function fx at plus 4. It will become 4 by 8 plus 2 by 4. How much is that? 1 by 2 plus 1 by 2. How much is that? Simply 1. Simply 1. This is correct. So option A is correct, sir. Please have a look. Okay? It's coming as 1, sir. Okay? Now, can I move on to the next question? The last question of the day. The maximum area of the rectangle inscribed in the circle. Okay? So we know this thing, right? Whenever you are inscribing a circle, bacha, and looking for a maximum area, this will happen only when it is a square. It is a square, sir. Okay? So, and the radius will be like this. Please check. So, this will be radius, this will be radius. We'll be having this point as the center O. Okay? So, when that happens, this is going to be again, what is that, sir? Diameter 2r. Okay? What is that, sir? This is going to be A. It's going to be A. Okay? So, we are looking to maximize the area. Alright? How much is the radius given here? So, radius given as, sir, 8 actually. Compare this. X plus 1 the square plus y minus 3 the square equals to 8 square. Hence, sir, r is nothing but 8, bacha. So, this bacha will be 2r equals to 16. Okay? So, I can write it over here. In this case, a square plus a square equals to 16 square. So 2a square equals to 16 square by 2, sorry, like that only, forgive me. It will become, so a square equals to 16 square by 2, giving me a square equals to 16 into 8. So I'm getting a square equals to 8, 1 plus 4 is 12, right? 128 is the value of a square. If a is the side of what? The square, what is the area, bacha? A square only. What is the answer going to be? 128 square units. Please check. It's a PYQ, right? It's a PYQ, so 2018 they have asked this question. So this is done, sir. This is done. Question number 5 is done. This is it for bacha your session on AOD. So I have tried to give you brief understanding, try to explain you all the concepts in detail in one shot only. Let me know if you something I have missed. If you want me to do something else also in this chapter, I'll do that certainly. So for now, this is it. I have done total of 5-6 questions today, and I learned all the chapters important points in one shot. Okay. So with this, I'm going to end the session today. Keep working hard, keep smiling. See you again. Take care. Bye bye.